In this video, we're going to talk about the point-slope form for a linear function. So a little bit different than slope-intercept, and we'll talk about what it looks like and what is given in the equation that we can see from the graph. That's exactly what the name says, the slope and a point from our line. And then we'll talk about how to graph from an equation and how to write the equation from a graph. And it's very similar steps to how we did this with slope-intercept. So point-slope form is y minus y1 equals m times parentheses x minus x1. So the y and the x are part of our equation, and then we take any point on our linear function and we plug that in for x1 and y1. So we substitute those in, and we substitute our slope in front of this quantity square, or this quantity here, and multiply that by a slope. Okay, so if we're given this equation here, we see that the -4 and the -1 represent one of the points on our graph, our linear function, and then our slope is -3. Remember, slope is rise over run, right? So we can easily see what that is here. But if we have an integer, positive or negative, we can just say over 1 to help us with that rise over run. But we can't really use the slope without a point on our graph to start from. So that's where the x1 and y1 come in. Recall that it's y minus y1. So the y1 value here is a +4. The x1 value is a +1. So I'm going to graph the point 1, 4. X equals 1 up to y equals 4. So there's 1 point on this function here. Now my slope is -3, or -3 over 1. So that means I can go down 3. Remember, down is negative direction, and to the right 1 because that's positive. So -3 over +1 is the same as -3 here. So I'm going to continue doing that a couple more times. Down 3 over 1, down 3 over 1. I can also go, and I don't really need to because I kind of run out of room here, but I can go up 3, which is positive, and left 1, which is negative direction. So +3 divided by -1 is also -3. So let me go ahead and draw my line through these points. I want to have more points across my graph than just a couple, so I get an accurate representation of my graph. If you just stop at 2 points, it might not be very accurate in your visual. So there is this equation here. Recall that if I take any point on this graph and I substitute the x and y value in, my equation should be equal. So if I plug in 0, 0, which is not part of my graph, 0, so 0 comes 0 for my y value, 0 for my x. 0 minus 4 is -4. And I have to do 0 minus 1, which is -1, times -3, which is a +3. And -4 is not equal to +3. So that holds true that, since this point is not on the line, the equation doesn't work. But if I use this point 2, 1, where 1 is my y value, 2 is my x value, 1 minus 4 is -3, and then I have to do -3 times 2 minus 1, because that's the part in parentheses here, and 2 minus 1 is 1, times -3 is -3, so that holds true. Go ahead and try to graph this one. So again, we have to start with some point on our graph, so we can use our slope to find more points. So I've got +3 for my x. Well, this is +5. I gotta make sure I don't put a +5 there because it's minus the value. So minus a -5 would be the same as plus. So this is going to be at 3, -5. Oh no. Okay. 3, -5 right here. And now my slope is -1/4. So I'm going to go down 1, right 4. That brings me to the edge of my graph. So I need to go the opposite direction. Up 1, left 4. We'll do one more. Up 1, left 4. Notice how both of these graphs from left to right they're decreasing. They're like going downhill. So that tells us that it is matching with the negative slope we have. All right, last part here. How would we write the equation of a graph? Well, we need to pick any point. Remember, it doesn't matter which point, they all work in the equation. So even though in point slope form, you can write infinitely many equations that represent the same line because you can use any point. So I'm going to let's use this one, 3, 3. So my x value is 3, so I do -3. My y value is 3, so I'm going to do y -3. And my slope, I go down 1, which is negative, and to the right 3, which is positive. So -1/3 for my slope. As always, when you count slope there, you want to double check that that's the same. So if I continue to go down 1/3, I get that point here, or up 1, left 3, up 1, left 3, those all seem to match. So there's your equation.